Hello viewers. So today we'll learn about the angle of intersection of two curves, right? Uh, Till now we have discussed the concept of angle between two lines, right? So in this lecture we are going to uh, find the angle of intersection of two curves, right? Now here let us consider the curves C1 and C2. Suppose the equation of the curve C1 is y is equal to f1x, and the equation of the curve C2 is y is equal to f2 of x, right? Now we have to find the angle of intersection between these two curves C1 and C2. Now here we see that C1 and C2 intersect at the point P, right? So point P is the point of intersection. Now we have to find the angle between these two curves. So the angle between these two curves is defined as the angle between the tangents to these two curves at the point of intersection. Now the definition of the angle of intersection of two curves is the angle of intersection of two curves is equal to the angle between the tangents to the curve at the point of intersection. So here the curve C1 and C2 intersect at this point P. So let us draw the tangents at this point P to the curves C1 and C2. Now here the tangent to the curve C1 it can be drawn like this, and the tangent to the curve C2 at this point uh, can be drawn like this, right? So this is the tangent. T2 is the tangent to the curve C2, and T1 is the tangent to the curve C1, right? Now the angle between T1 and T2 is known as the angle of intersection of these two curves. Now here we have this tangent T1 and this is tangent T2. Now if theta is the acute angle, right? If theta is the acute angle between the two lines, that is the two tangents T1 and T2, and let us say this is the angle theta, right? So theta is the acute angle between these two tangents, and this is the obtuse angle, that is pi minus theta, right? And if the slope of this tangent T1 is m1 and the slope of this tangent T2 is m2, then we know that the angle between two lines, right? The angle between two lines T1 and T2 is given by tan theta is equal to the absolute value of m1 minus m2 divided by 1 plus m1 times m2, right? So here we have the two curves C1 and C2, right? We have drawn the tangents T1 and T2. Now these two tangents are inclined at an angle theta, and theta is the acute angle and pi minus theta is the obtuse angle, right? So the angle between these two curves is the same as the angle between the two tangents, and the angle between the two tangents can be calculated by this formula, that is tan theta is equal to the absolute value of m1 minus m2 divided by 1 plus m1 m2, right? Now let us see the concept of orthogonal curves. Now two curves C1 and C2 are said to be orthogonal curves if the angle between the tangents T1 and T2 to the curves C1 and C2 at the point of intersection P is 90 degree, right? So it means if this angle, right, if this angle theta is 90 degrees or pi by 2, then we say that the two curves C1 and C2 intersect orthogonally, right? So if the tangent T1 is perpendicular to the tangent T2 at this point of intersection, then the two curves are said to be orthogonal, right? And the condition for the two curves to be orthogonal is m1 times m2 should be equal to minus 1, right? So the product of the slopes of the two tangents at the point of intersection to the two curves should be equal to minus 1. Then the curves are said to be orthogonal. Now suppose the coordinates of this point P are, say, alpha comma beta, right? Now the condition of the two curves to be orthogonal is the product of the two slopes should be equal to minus 1. So we can write m1 is equal to the slope of this tangent t1, so dy over dx at this point alpha beta, right? And m2 is the slope of this tangent at the point alpha comma beta, right? So the product of these two slopes should be equal to minus 1. So we can write dy over dx at the point alpha comma beta multiplied, here we have again dy over dx, or we can write it as this is the slope 1 and this is the slope 2. So here we have 1 multiplied dy over dx, and this is 2, and alpha comma beta is equal to minus 1. So the product of the two slopes should be equal to minus 1, so that the two curves intersect orthogonally. Now let us solve some problems related to the angle of intersection of two curves, right? So the first problem is show that the two curves x cube minus 3x square plus 2 equal to 0 and 3x square y minus y cube is equal to 2 cut at right angles. So here the equation of the first curve, that is C1, is given as x1 cube minus 3xy square plus 2 is equal to 0, and the equation of the curve C2 is 3x square y minus y cube minus 2 is equal to 0, right? Now what we will do, we'll find the slope of the tangent from this curve C1 and the slope of the tangent to this curve C2. So it means from here we'll find the value of dy over dx, and from here also we'll find dy over dx. So let us differentiate this equation. So we have 3x square minus, and here we have minus 3, and for xy square we'll apply the product rule. So we have x first function, then derivative of second, 2y dy over dx plus y square times 1, and here we have 0, that is equal to 0. So differentiating this equation, we'll get this one. So now if we simplify it, then we get x square dividing throughout by 3. So we have x square minus 2xy dy over dx minus y square is equal to 0. So dy over dx is equal to x square minus y square over 2xy, right? So this is the slope of the tangent to this curve C1 at some point x comma y, right? Now again differentiate this equation, right? So we have 3 x square times dy over dx plus y times 2x, and then we have minus 3y square dy over dx minus 0 equal to 0, right? Now simplifying it and dividing throughout by 3, we have x square dy over dx plus 2xy minus 3y square dy over dx equal to 0. So here we will not have this 3 because we have already divided this equation by 3, right? Now from this equation we have dy over dx x square minus y square is equal to minus 2xy, and dy over dx is equal to minus 2xy over x square minus y square. So this is the slope of the tangent to this curve C2, right? Now so here we have m1 and here we have m2. So let us find the product of these two slopes, m1 times m2, right? So m1 is x square minus y square over 2xy, and here we have minus 2xy over x square minus y square. Now here these two terms get cancelled, here 2xy and 2xy get cancelled, so we are left with minus 1. So it means the product of the two slopes is equal to minus 1. Thus we can say that these two curves cut at right angles, or the two curves C1 and C2 are orthogonal curves. Now let us take this problem. Here we have to find the angle of intersection of the curves, right? So here the first curve C1 is y is equal to 4 minus x square, and the second curve is y is equal to x square, right? So now what we will do to find the angle of intersection of these two curves, we'll make use of this formula, that is tan theta is equal to absolute value of m1 minus m2 divided by 1 plus m1 m2. So this is the angle between two lines, right? Now m1 is the slope of the tangent to this curve, that is the curve number 1. So m1 is dy over dx, and from here we have dy over dx is equal to minus 2x, right? And m2 is the slope of the tangent to the curve number 2. So this is dy over dx, and here dy over dx is 2x, right? So now m1 is minus 2x and m2 is 2x, right? Now let us take a point P as alpha comma beta, which is the point of intersection of these two curves, right? Okay, so now m1 is equal to minus 2 alpha at this point, that is alpha comma beta, and m2 is the slope at this point alpha comma beta. So here we have 2 alpha, right? Now let us substitute this value in this formula number 1. So tan theta is equal to minus 2 alpha divided by 1 plus minus 2 alpha times 2 alpha, right? So this is minus 4 alpha divided by 1 minus 4 alpha square, right? So now here we have tan theta is equal to absolute value of minus 4 alpha divided by 1 minus 4 alpha square. Now here uh, if we now know the value of alpha, then we can find out this angle theta, right? So in order to find out the value of alpha, uh, we see that this point P is the point of intersection. This is the point of intersection. So this point P is the point of intersection of these two curves C1 and C2. Then this point P, it will satisfy these two equations. So substituting this value in C1, we have beta is equal to 4 minus alpha square, and substituting this point in C2, we have beta is equal to alpha square, right? Because this point P is a common point lying on these two curves, so it will satisfy these two equations. Now solving these two equations, we have 4 minus alpha square is equal to alpha square, and from here we have 4 is equal to alpha square plus alpha square, that is 4 is equal to 2 alpha square, and alpha square is 2, so it means alpha is equal to square root of 2, right? Now let us substitute this value of alpha square and alpha in this equation. So what we will have, so tan theta is equal to absolute value of minus 4 times alpha. Alpha is root 2, and here we have 1 minus 4 times alpha square is 2. Now this is mod of minus 4 root 2 divided by 1 minus 8, that is minus 7. So minus and minus get cancelled, so we are left with 4 root 2 by 7, that is equal to 4 root 2 by 7. So therefore the value of tan theta is 4 root 2 by 7, and theta is equal to tan inverse 4 root 2 by 7. So this is the required angle of intersection of these two curves. Now let us take an interesting problem. Here we have to find the condition that the curves, this curve 2x equal to y square, let us say this is curve C1, and 2xy is equal to k, this is curve C2. These two curves intersect orthogonally. So it means this curve C1 and C2 intersect orthogonally. It means the tangent to these two curves at the point of intersection of C1 and C2 are perpendicular to each other, right? So here what we will do, we'll find the slope of the tangent to this curve, that is m1 is equal to dy over dx. Then we'll find the slope of the tangent to this curve C2, which is dy over dx, right? Now let us find dy over dx for this curve. So differentiating both sides, will have 2y dy over dx is equal to 2, right? Differentiating both sides, so this is 2y, then dy over dx, that is equal to 2. The derivative of x is 1. So here this 2 and 2 get cancelled, so dy over dx is equal to 1 over y, right? Okay, now this is m1, and for this curve C2, let us differentiate both sides with respect to x. So we have 2 xy is equal to k, which can be written as xy is equal to k over 2. Now differentiating both sides, we have x, the product rule will be followed here, so x dy over dx plus y times 1, and here we have 0 because k by 2 is a constant. So dy over dx can be written as minus y over x. So this is m2, right? Now if this curve is say c1 and this is curve c2, then this is the point of intersection of c1 and c2, and let us say these 2 points, this point is alpha comma beta. So at point P alpha comma beta, m1 can be written as 1 over beta, because this is the value of y, this is the value of x, right? And m2 is equal to minus beta over alpha, right? Now here we are given that the two curves intersect orthogonally. So the two curves to be orthogonal, the condition is the product of the slopes should be equal to minus 1. So m1 is 1 over beta, m2 is minus beta over alpha, that is equal to minus 1. So here beta and beta get cancelled. So we have minus 1 over alpha is equal to minus 1. So alpha is equal to 1, right? So the value of alpha is 1. Now we have to find the value of beta, and we know that this point P lies on the curve C1 and C2. So if we substitute this point in this equation, then we have 2 alpha is equal to beta square, right? So alpha is 1, so here we have 2 times 1 is equal to beta square. So beta is equal to square root of 2. So alpha is 1 and beta is square root of 2. Now substituting these two values in this equation, we have 2 times of x is alpha, y is beta is equal to k, right? Now 2 times alpha is 1, beta is the square root of 2, that is equal to k. So the value of k is 2 root 2. So this is the condition for these two curves to intersect orthogonally.